In this video, we're going to learn how to find the monthly payment for a student loan. And this is the payment that the student will start making after they have graduated school and they are finished with the deferment period and they're ready to just pay back their loan. So to do that, we're going to use a monthly payment formula that you see right here. And the variables are on the right-hand side. Some of these are very similar to variables you've seen before in like the simple and compound interest formulas. So rate is still in a decimal form and lowercase r. T stands for time in years. In this case, we write term of loan, but it means the same thing. So how long is it going to take the student to pay off in years? Usually 10 years for student loans. So that's the most common term for student loans, but it is possible to have terms of different lengths. And so before we jump into an example where we use this formula, let's talk about how we could look at the interest and how that might change depending on the type of the loan. So there's two main types of loans, subsidized and unsubsidized. And this describes how the interest is paid while the student is in school. So if the accrued interest is paid by the government, then that means it's a subsidized loan. That's ideal. So that's what students, if they had a choice, they would pick that kind of loan because the government is absorbing all of that interest. And so when they graduate and they're ready to make payments, the principal is just the loan amount. There isn't an additional amount that's tacked on for interest. Now keep in mind that even with subsidized loans, students will still end up paying interest. They'll pay interest the entire time that they're paying off the loan when they're making payments. So perhaps a whole 10 years of interest, but they just won't have to pay interest when they are in school. And then an unsubsidized loan, that means interest is accrued while the student is in school and the government is not paying it. So there are two options in terms of how that gets paid. So with capitalized interest, the accrued interest is paid by the student after they finish school. And this is also after the deferment period. So usually they get 6 months after school, and then once that's finished, then they have to start making payments. And the principal is going to be the loan amount, so whatever they borrow, plus any accrued interest. With uncapitalized interest, it's still underneath unsubsidized loan, so it means that the student is still paying this interest. The government is not, but the accrued interest is paid by the student while they are in school. Or even in the deferment period, and in the deferment period. And in this case, this is really helpful for the student if they're able to make these payments, because what happens is when they finish school, the principal that goes into figuring out their monthly payment for their student loan is just the loan amount. So they don't have to tack on any extra interest fee like they do with this capitalized interest. So let's go ahead and look at an example. So in this example, we're using a previous example that I did in the last video about Piper. And Piper borrows $4,500 at the start of community college, spends 2 years there, transfers to a university, and then graduates 2 years and 3 months later, and then has a deferment period of 6 months. Her loan rate is 5.2%. Find her accrued interest. So that was the problem. So in the last video, we found that the accrued interest was $1,094.40. And if you don't remember that, you should go back and watch that before doing the rest of this problem. So that was the amount of interest that added up while Piper was in school. Now what we're going to do is we're going to assume Piper has finished school and the 6-month deferment period is over, and we're going to calculate her monthly payment that she's going to make. And we're going to assume here that T, the term, is 10 years. And so let's consider what the principal would be depending on the type of loan. So it doesn't give us any information here about the type of loan. So what I want to do is actually go through each different type, and we'll figure out the principal and monthly payment for each. So that way, when we're done here, you'll hopefully know how to do it for any of these scenarios. So the first one, subsidized loan, remember the government pays the interest. So the principal, when we try to find the monthly payment, is just going to be the loan amount. We don't have to tack on any interest from when she was in school. And the same is going to be true for an unsubsidized loan with uncapitalized interest, because remember, with this option, the student is paying that interest while they're in school. So the principal, when they're done with school, is still $4,500. The second option, so the unsubsidized loan with capitalized interest, that principal is going to be the $4,500 plus that interest that accrued while Piper was in school, plus $1,094.40. And so if you add those two numbers, you get $5,594.40. So you can see the principal has increased there just due to the fact that the government wasn't paying interest, and either was she while she was in school. So now we're going to find the monthly payments, and option A and C are really the same because the principals are the same. So I'm going to break this up into two problems. So the first one is going to be if the principal equals $4,500, and then we're going to go through the formula with that assumption. So I'm going to use the monthly payment formula. R stands for monthly payment, so R equals the principal times the rate, which is 0.052, because it says in the problem that the rate is 5.2%. So if we drop the percent sign and move the decimal 2 spots to the left, we get 0.052. And then divided by 12, and then in the denominator, and I'm going to write the parentheses exactly how they're written in the formula. I'm just going to substitute any of the numbers that I have for the variables. So divided by 12, and then to the negative 12 times t, so t is 10, power. And so you have a couple of options here. If you have a TI-34 or TI-30 calculator, you can use this N over D button, and I'll show you that first. So click the N over D button, and then you can type it in exactly how it's written here. And then times, or parentheses, N over D, 0.052, down arrow 12. Make sure you hit the right arrow to get out of that fraction, because otherwise that'll just become a big mess. And then press the down arrow, and then parentheses 1 minus, parentheses 1 plus. I can put the fraction button again, 0.052 divided by 12, and then I want to get out of that fraction, end parenthesis, and now I want to do my exponent. And actually I'm noticing here I should have actually put another parenthesis there to model the parenthesis up here in the formula. And so I'm going to use my exponent key, and then make sure you hit the negative sign and not the minus sign, because they're not the same. If you hit the subtraction sign, your calculator will give you an error. So you're going to do negative 12 times 10. And then you can actually hit enter here, but you could also hit the right arrow to get out of that exponent and end those parentheses. So then we get a monthly payment, and we want to round this to the nearest cent or hundredths place, two numbers after the decimal. So that'd be 17 cents, and this is per month. So that would be the monthly payment she would make for 10 years. So that's a long time. And then if you don't have this type of calculator, what you could do is do it step by step. So I would just type in 4,500, and then I'm going to pretend like I don't have a fraction button. So if I had a graphing calculator, just a scientific, either parenthesis, or you can just use the times button, 0.052 divided by 12 equals, and so your numerator, I'm just going to write that down as 19.5. And then what you're going to want to do is you're going to want to do the denominator. And so this just depends what kind of calculator you have. Hopefully you have parentheses. If you do, you can just put it all in exactly how it looks, only we're just not going to use that fraction button. So when it gets to this part right here, we're just going to say plus 0.052 divided by 12, parenthesis, and then raised to the you can either do negative 12 times 10, or you could do that ahead of time. Like you could work that out ahead of time and write negative 120. So that way you could just plug that in. And then you could end those parentheses and hit enter, and then you have the denominator. And so then you could just divide those two numbers. And most calculators have an answer button that will allow you to automatically substitute that last answer in. So if I use that, I could do 19.5 divided by, and then second minus, and depending on the calculator, it might be in a different location, but you find the answer key and then it'll just automatically plug in that last answer for you, so you don't have to type it all out. And if you don't want to do that, you can certainly type it all out and you should get the same thing regardless. So doing it this way, we get 48.17 a month too. So you shouldn't worry about the calculator you have, because regardless, you should be able to do the problem, just maybe approach it a little bit differently. So that would be the monthly payment. I'm just going to fill in the blanks here, $48.17 for the subsidized loan and the unsubsidized loan with uncapitalized interest. So now I'm going to do the second one. So an unsubsidized loan with capitalized interest, which has that different principal. So if the principal is $55.94.40, it's larger than the other principal. So we're probably going to get a higher monthly payment. Let's see how high it gets. So I'm just going to do the same thing I did before, with the only change being the principal. Everything else stays the same. So I'm just copying down what I have here on the left-hand side. And then I'm going to put it in my calculator. And so I'm going to do the numerator, 55.94.40 times 0.052 divided by 12. Oh, and you know what? I didn't hit the N over D button. So you know what I'm going to do? I'm just going to hit enter there, and I'm going to write out the numerator. Let's just do it like that. And so I get 24.2424 on the top. And then on the bottom, I could put in 1 minus 1 plus 0.052 divided by 12, end parenthesis, and then raised to the negative 12 times 10 power. And then I'm going to use the right arrow to get out of that exponent position, and then hit enter, and I get the denominator 0.404811179. And notice that's the exact same. I didn't even really need to calculate that, because that's the exact same as the denominator over here. The only thing that changed was the numerator. And so now I'm going to divide these two numbers. So 24.2424 divided by, I'm going to do second answer instead of typing this all out, but you could certainly type that all out. And then I get a monthly payment of 59. It would be 89, since that 5 tells me to move that 8 up. And so that would be my monthly payment. So quite a bit higher. So you can see there, and you may think, you know, what's the big deal? It's only $10 a month, but also consider it's $10 per month. There's 12 months in a year, 10 years, that's 120 payments. And so 120 payments times $10 a month, you're looking at $1,200 more that the student is paying over the life of the loan, just for not paying that interest while in school. So hopefully that makes some sense. And as always, if you have any questions, just reach out to your instructor.